All right, so again, constant multiple. So if there's a coefficient in front, we could just pull it outside of the integral symbol, right? So if the k is here, we move it in front. Obviously, if you have two functions that are added, you can find the area under this one plus the area under this one. Okay. And the last one is additivity. So if you have the area from A to B plus the area from B to C, you can just combine them all into one area. Okay. All right. All right, so here we know the integral from -1 to 1 of f of x dx is 5, from 1 to 4 is -2, -1 to 1 of h of x is equal to 7. All right. So, first one, what do we notice about the limits of integration? Lower numbers on the top, so we're going to switch that. So it's going to be from 1 to 4 of f of x dx, but the opposite. So positive 2. Okay. -1 to 4 of f of x dx. 3. Do we see how we got that? Because we know from -1 to 1, and then from 1 to 4. So if this is 5 minus 2 gives us 3. Now the key is that these two, remember, those are the two that have to be the same. The next one, from -1 to 1 of f of x plus h of x. Yeah, 12. Okay. What about from 0 to 1 of f of x dx? Oh, can we find that? Do we have any information about from 0 to 1?
You divide that one by 2.
Okay, if we knew that this was an even function, if it had symmetry, then we could divide it by 2, but we can't make that assumption, so not enough information. Okay. Same thing, right? Again, from -2 to 2, we can't just multiply this by 2. Unless, again, we knew that was an even function, if it had that symmetry. So not enough info. Linear. I mean, if we knew the actual function, then we would be able to figure out the area to the curve. But we don't know anything other than the area between those two. Okay, and then the last one, what can we do? 3. So the 3, it would be 3 times 5 minus 7. Okay, good. Questions? Bless you. Okay, so I'm going to jump ahead to chapter 7. Yeah.
The one we just did be 3 times 5, not like 5 minus 7
No, because it's just 3 times f of x. Yeah. If the 3 was all the way in the front, then. Okay. So we are going to jump ahead to properties of indefinite integrals. Okay. Right, so the derivative of f of x is f prime of x, which means if we take the integral of f prime of x, that ends up giving us f of x plus some constant c. All right, because when we're working backwards, if we don't know the limits of integration, we can't find the actual area under the curve. But we can find a formula for the area under the curve. And that's what we're going to do first. Okay, so, I guess we already did these two. Let's look at the power formula. So working backwards from the derivative. So if we have something to the nth power, we're going to add 1 to that power and divide by that new power. So an example, let's see. Let's say it's x to the 7th power. X to the 8th power divided by 8. And then we'll put this plus c at the end. How can we check our answer? We'd just do the derivative. So if I did the derivative of this, right, the 8 would come to the front to the 7th power. The 8s would cancel. Obviously, the derivative of that constant just becomes 0. Okay, now this rule applies to any power except -1. Because what would happen if I try it with -1? Yeah, you'd get x to the 0 power over 0. So the one exception ends up giving us natural log. And we're going to put that natural log in absolute value. Again, think about if we were to do the derivative of this. What's the derivative of natural log? 1 over. Trig functions. Okay, so just working backwards. So if I take the integral of cosine, that's going to give me sine, right? Because the derivative of sine is cosine. It's all flipped, right? So if I'm going to take the integral of sine, I get negative cosine. If I take the integral of secant squared, that gives me tangent. I'm just going to highlight these because I'm not going to put these on a test or quiz and you won't have it on the AP. So these are the ones that you have to memorize, okay? Those have to memorize. All right, exponential and logarithmic. Hopefully that one makes sense. Antiderivative of e to the u is e to the u because the derivative of e. All right, and then working backwards, what if it's anything other than e, like 2? Oh, yes.
Okay, so I've been showing him around getting to his locker. He's got Jewish studies next. Is there someone who
Jewish
make
studies?
sure we take him? It's a new 11th grader.
Jewish studies. Anybody have Jewish studies next?
Environment.
I'm in that class.
Okay, so you can go with Rick.
Perfect.
They'll help you. Okay.
Anywhere. Yeah. You know what? Okay, so I was going to give you a quick example. This one.
You know that when they wash your hair before
They massage your hair.
Yeah.
Oh my gosh, the best. That's the best part of the haircut.
That's
See,
the
that's
best.
a love-hate relationship.
Yeah,
That's a
yeah,
love-hate
yeah,
relationship.
yeah,
When they're
yeah.
washing my hair, I love them. Then when they're cutting it, I hate them.
What is all y'all talking
Okay, so integral.
Give me like an exact date.
And we're back. Let's focus. 2 to the x. What's that going to become? 2 to the x over natural log of 2
Wait, what?
plus c.
Oh, yeah.
Well, listen, if it was e to
No,
the x.
wait, but isn't it the U? It's the U-X.
The U
I
is
love you.
Excuse me, did you pause the screencast where you were talking about this whole thing?
I mean, I paused and then I just hit record.
Wait,
See, now I'm
if
talking
you
Ellen of
did
X.
Ellen of U, so wouldn't it be Ellen of X?
Oh, you know what? That's a typo. That should be ln of a. Sorry, good catch. That should be. Okay, and then remember the derivative for tangent inverse is 1 over 1 plus x squared. So the antiderivative of 1 over 1 plus x squared is tangent inverse of x. And then sine inverse, right? So working backwards. Okay, good. Questions? All right. So this is what we're going to practice. Okay, so if we have, and if you have to flip back and forth, that's fine. So the power rule is one of those rules, just like with derivatives, we're going to use it very often. So if it's x squared, what's that going to become? X cubed over 3. Okay, don't forget, indefinite means all of these have to have a plus c afterwards, because again, if we don't have limits of integration, we can't actually find the area under the curve. Okay.
Is it just like C? Like, do not like do anything with C?
We don't do anything with C.
Okay,
Well,
great.
later on, we'll actually be able to solve for C.
Do you need plus C after every single thing?
For all of
Every
these,
single one's plus C.
every single
Doesn't
one is
matter.
plus C.
Every single one.
Okay. If you know the limits of integration, then your answer is going to be an actual number. Okay. But right now we can't figure out what this is. We can just find out the formulas for it.
Mm-hmm.
Okay. Integral of 2 cosine x will be 2 plus c. Good. Okay. And when I say integral or antiderivative, they're like one and the same. Okay. So I can say, what's the antiderivative of e to the x? E to the x plus c. Okay. All right. Now, remember the coefficients, they don't change, right? So if it's 2x to the third, it will be 2x to the fourth over 4, which we can reduce that, which we're going to want to, minus 3x cubed over 3 plus 8x squared over 2. What happens with the constant at the end?
4.
Okay, so it has a power of 0, so it becomes 4x plus c. Right. So if it's a constant, technically that's a 4x to the 0 power, right? Remember, if this was, it's a degree of 0. All right, and then let's just simplify that. So what do we get? X to the 4th over 2 minus x cubed plus 4x squared plus 4x plus c. How about the next one? So we have 3x plus 2x to the 4th. So it's going to be 2x to the 5th over 5.
Plus C once. Or do I have to do like 3e to the x plus c plus 2x to the 5 plus c?
You're saying like in the final answer. As long as you include it in the final
It just
answer.
like
that's
it's just
fine.
be once.
Yeah.
I'm over. I'm out.
Okay. All right, keep in mind that's x to the 1/2, so we can still apply that power rule. But the first one is going to be 6x squared over 2, which makes it 3x squared. And what happens with x to the 1/2? It's going to be x to the 3/2 over 3/2.
Would it be minus?
Oh, thank you for the, yeah, that should be minus. So, we get 3x squared minus 2/3 x to the 3/2 plus c. Yeah, I mean, later on we're actually going to evaluate numbers. But remember, x to the 3/2, that's just square root of something to the 3rd power. Okay. Okay, x to the negative 2, x to the negative 1 over negative 1. remember the power rule is just the reverse for derivatives, right? Yeah, let's rewrite that as
You just add one.
yeah.
Right?
Sometimes with the trig, the hardest part is just remembering what the positive negative, because we can get those confused with derivatives. So just remember to check. You can always just do the derivative of your answer to make sure you get back our integral. Okay. Integral of negative sine x cosine. Okay. Okay, what's this one? E to the x
X to the 1/3.
So over 1/3, so that's going to become e to the x plus 3x to the 1/3 plus c. Oh, it doesn't matter. I mean, you could, again, when we actually evaluate these with numbers, you're going to want to think of it as cube root. But for right now, it doesn't matter to me whether you leave it as 1/3 or cube root. Okay, and then the last one, 4 square root of x will become
4x to the 1/2.
well, yeah, this is x to the 1/2, so it's going to become 4x to the 3/2 over 3/2 plus c. So that's going to become yeah, 8 over 3. Again, I don't care if you write it 8/3 times x to the 3/2. It doesn't, makes no difference. All right. That was easy, right? No? No, sorry. Okay, I won't say anything. I won't say anything.
It's a good
Yeah,
lesson
we're done.
for first day back.
That's what I figured. It's a nice,
But
easy.
6-3 continue.
I know. So we're spending 2. If we looked at the lesson plan,
My lesson was
you just made her so sad. Seriously.
I think I'll work well.
Well, yeah.
Oh, no?
I know, but